All right, good morning. So today we're going to be talking a little about the hierarchy of matter, right? So we're going to talk about some different parts of matter, and we're going to try to classify different materials based on those categories that we're going to discuss today. So the first thing is we're going to go over some definitions. So I've put them up over here. These are the same ones that you can get from chapter 1 inside of your book. And so what we want to think about is remember that matter is going to be anything that occupies both space and has mass, right? So things that aren't matter will be things that are energy, which we'll be talking about later on in the course. But anything that has mass and takes up space is going to be matter. So that could be like oxygen, that could be a piece of iron, that could be chicken noodle soup, right? Those are all different types of matter, right? And so that's why we have to have a hierarchy or a classification of matter, because we want to start to separate that matter into different groups. So the first one is we're going to have something that we call pure substances. Now, pure substances is when there's only one type of matter that's present. And we're going to go over a little bit of details about what exactly that means. But this means that you only have one thing, right? So we only have one thing that's there. Anytime that you have more than one type of matter, that's what we're going to get when we call a mixture. So if you have only one single type of matter, you're a pure substance. If you have more than one type of matter, you're now going to be called a mixture. And so within our mixture, we have a smaller set of categories in there. One is called a homogeneous mixture, which is going to be something that's identical throughout or the same throughout. Another one is going to be called the heterogeneous mixture. And that's going to mean that you can see differences inside of it. It means it's not the same throughout. Now, we might use some other terminology that's related to this. One of those is called solutions, right? So you might have heard about solutions. You might have an eye wash solution for your contacts. You might have a cleaning solution when you clean the house. Right? Solutions is an example of a homogeneous mixture. Right? Now, a lot of times we think of it as just being liquids, but that doesn't have to be the case. And we'll go over solutions a little bit later in chapter 12 when we talk about how you make them. Okay. So those are our beginning terms. So let's look at these three different pieces of matter and let's try to classify them. So we have pure water, we have lemonade from a powdered mix, and we have lemonade from freshly squeezed lemons. And so we're going to look into these circles, these zoomed in parts of the solutions, or not the solutions, of the substances. And we're going to try to see how we could classify them. So we're going to try to classify those three, pure water, powdered lemonade, and fresh squeezed lemonade, as either being a pure substance, a homogeneous mixture, or a heterogeneous mixture. So go ahead and pause the video, take a moment, make your hypothesis about what you think they should be, and we're going to discuss those. So looking at our picture, when we have pure water, we want to think, is that going to be just one type of material or is it several types of material? Right? And pure water is just one type of material. It's only water, which is H2O. You might not know the chemical formula of water. That's okay. You don't have to know that yet. But it's just the water inside of there. Lemonade from the powder mix, on the other hand, is made up of two different types of matter. We have the water, and then you have your powdered mix. And then we mix those together to form that one material, the lemonade from the powder mix. And so we know that both the lemonades must be different types of mixtures because they are each having more than one substance. Now, the difference between them is that when we have it from the freshly squeezed lemons, we're going to see a difference inside of that solution. Some places there's going to be pulp or seeds or sugar. Whereas if we do the lemonade from the powder mix very well, it's going to be the uniform throughout, right? And so that's how we're going to start to separate those between a homogeneous mixture and a heterogeneous. So when we're looking at this, our pure water is going to be classified as a pure substance because it was only one type of material in there. Our powdered lemonade is going to become our homogeneous mixture. And that's because it's going to be the same throughout. A fresh squeezed lemonade is going to be our heterogeneous mixture because there's some separation, or it's not uniform. You can also think of something like tomato soup versus chicken noodle soup. Tomato soup is uniform throughout, right? And so that would be a homogeneous mixture. Chicken noodle soup, you have the noodles, you have the chicken. And so unless you blend it all into a puree it all so that it's the same throughout, it's not. You're going to see different pieces inside. And that is going to be our heterogeneous mixture. Now, when we're trying to think about whether something is a substance or not, one of the things that we want to talk about is we're going to introduce a couple more terms. So we're going to introduce the term of elements and atoms. Now, elements are the basic building block of matter, and it's a pure substance that we can't break down into simpler substances. So if you look at this block, this collection of Legos over on that right-hand side, elements are kind of like each color of the Legos. We can't make them simpler colors. They're all just that color that it is. And then atoms is kind of like the smallest piece of an element. So it's that smallest Lego piece inside. So this block up here is all one element. It's all the light blue element, but it might be 4 different atoms connected together. Whereas this one over here, this blue one, is a single element, blue, and it's the smallest piece of that single element. So it's an atom. Now, when we talk about elements and we're saying that we can't break them down, it means that using chemical means, so chemistry and some chemical reactions, we can't make them simpler. Now, it's pretty easy to tell whether or not you have an element. When you first came in, I gave you a periodic table today. And so on that periodic table is all of the elements that we know. All right, so there's 118 of them that we've identified. 82 of them naturally occur. 36 of them we've kind of synthesized through artificial means. But those are our basic elements. So if you're not sure if something is an element or not, maybe it's a term that you're not familiar with, right? Maybe you've never heard of yttrium. One way to check is you can look on your periodic table and see if it's there. If it's not listed on that periodic table, unless you've managed to find a new element, which would be really cool, it's probably not an element, and it's probably some type of shorthand name for a combination of them. So when we're looking at these pure substances, these ones made up of just one material, there's 2 ways that that can happen. We can have what we call an elemental substance, where the whole thing is just made up of one type of element. Now that could be something like nitrogen gas, which is 2 nitrogens stuck together. It could be something like helium, which is just 1 atom of helium. It could be aluminum foil, which is just all aluminum metal. And so as long as it's one pure substance, as long as it's one element making up that entire substance, then we call it an elemental substance. On the other side, we could have something that we call a compound. Now, compounds are basically one substance, but they're made up of 2 or more different types of elements put together. Now, these elements aren't just mixed, they're chemically fused or bonded together. And so water was our example of a pure substance, and it's made up of 1 hydrogen or 1 oxygen and 2 hydrogens. So that's our H2O. Another example that you might have heard of is carbon dioxide. Carbon dioxide is made up of 1 carbon and 2 oxygens. And so as we work through the class, you get more and more familiar with these different types of compounds. Now, as you can see, I already have started writing them in their chemical formulas. And we're going to work through how you break those apart, but I just wanted to introduce that term to you. A chemical formula, it kind of lets us know the recipe of those compounds. It indicates the number of atoms of each element that make up that piece of that compound. So it's kind of our number of atoms inside of what we call a molecule, which is the unit together. And so that's kind of what we're looking for. So as a summary of this, what I want you to do is go ahead and take a practice of this. We have our different terms in here, and we should see how they're connected together. So go ahead and create a diagram to kind of organize these thoughts. Now you can do a traditional hierarchy where you can have a starting point and you can show how it splits. You can do circles, showing you different categories. You can even try to do it as a pyramid. There's no wrong way to create this diagram. But what we want to identify, or what we want to highlight, is which parts can be part of what other things. So as an example of this, a pure substance is still classified as part of matter, but not all matter are pure substances. An elemental substance is an example of a pure substance, which is an example of matter, but not all matter is pure substances, and not all matter are elemental substances. So we're trying to kind of show where those different categories fit, so we can start to separate those. This is an example of the one that I like to create. I like this one because I like to show that all of our matter kind of classifies on this outer part. And then inside of that, we have our two separate distinct categories of our pure substances versus our mixtures. Now, inside of those pure substances, I further separated them into elemental substances and our compound. And those are clearly distinct because there's no overlap between them. You can either be made up of only one element, or you can be made up of several elements. There's not an overlap there. Mixtures, on the other hand, though, mixtures, I like to squeeze these two together. And that's because sometimes it can be hard with a mixture to tell whether we're completely homogeneous or we're completely heterogeneous. There's a little bit of gray area in there. Right? And it all depends on your point of view or your perspective. Right? It depends on how far you're looking in. If you look across the room of where you're sitting, when you look at that wall, it might look all uniform. There might not be any distinctions. But as you start to come in closer to it, as you walk closer, maybe there's a smudge on it. Maybe there's a hole from where you hung a painting. Right? Maybe there's just other colors mixed inside. That's all part of mixtures. And how do you define whether something is completely uniform or whether something has a little bit of separation? And so for our class, we're going to try to choose very clear examples of that. And we're going to try to base it just on our observation. So we're just going to use our eyes for these, unless we specifically say like under a microscope or from this picture shown. And so go ahead and see how you did with your diagram. You could have another one. This is how your book likes to separate them. And now what you're going to do is you're going to go onto the discussion board and you're going to post up a material. And so it can be any material that you want. And then your classmates are going to help you identify whether it's a homogeneous mixture, a heterogeneous mixture, a compound, or an elemental substance. And then from there, we're going to double check and see if we all agree.